Good morning to one and all. Myself Divya. Today my topic is about design of DNA digital circuits. So first let us know what is the DNA digital logic. Digital logic is taught globally in most of all engineering schools. The subject consists of elementary knowledge of Boolean algebra, simple logical gates. Boolean algebra is nothing but addition, subtraction, multiplication, division, modular division, etc. Logical gates are AND gates, OR gate, NOR gate, XNOR, XNOR, OR gate, etc. Design of an elementary computer. With the help of AND or NOT, we can make any digital circuit. Recently, there has been increasing interest in the creation of deoxyribonucleic acid. DNA is also known as deoxyribonucleic acid logic gate due to the forthcoming application in the medical field. This article explains the elementary idea about and or not gate based on DNA strand displacement. Once these gates are made, the path to developing any DNA digital circuit becomes open. DNA gate can be used for both DNA logic circuit and DNA computers. In this article, we will provide the fundamentals of DNA circuit with the possible applications. DNA as a computing device. DNA is nothing but deoxyribonucleic acid. The idea of using DNA as a computing device has attracted many research since DNA can restore data in its strands. We know that the information stored in the human genome is enormous. With the development of modern synthesis tool, it could be possible to make DNA strands with the desired base pair. DNA has the highest data design compared to all other storage techniques available in the market. DNA digital circuit refer to circuit that that use DNA molecules as the building blocks for storing and processing information. So DNA digital circuit refers to the circuit that uses DNA modules as building blocks to store the information or to process the information. These circuits are designed to perform logical operation similar to the traditional electronic digital circuit, but they utilize the unique properties of DNA for computing. logical operations. We have computing device, computing device, logical operations, and logical operations. These are used in logical operations, arithmetic operations, simple logic gates, and to design the computer. At the core of DNA digital circuit designs are DNA logic gates. These gates perform logical operations such as D, A, and, or, NOR, XOR using DNA strands as an input and output. Each logic gate is designed to have specific DNA sequence that reacts with each other in a predictable manner based on complementary base pairing. Each logic gate is designed to have a specific DNA sequence that reacts with each other to perform logical operations such as AND or NOT XOR using DNA strands as inputs and outputs that react with each other in a predictable manner based on complementary base pairing. And when we see in AND gate, the truth table of AND is when two inputs are 0, it is 0. If any input is 0, the output will be 0. If all ones, there will output will be 1. Whereas in OR gate, it is reverse of it. When two inputs are 0 or two inputs are 1s, it's it gives if two inputs are 0, then only its output as 0. If any out if any input is 1 containing 1, then its output is 1. NOT gate is nothing but complement, such as 0 complement is 1 and 1's complement is 0. Analog circuit using DNA. DNA circuits are not limited to digital only. There are different analog circuits reported in a literature as well. Analog circuits are preferred over digital circuits. Not limited to the digital circuits, there are different analog circuits. In a resource limited environment, such as inside a cell, arithmetic circuits which can perform basic operations, whereas digital circuit is a resource limited environment, whereas arithmetic perform basic operation such as addition, subtraction, multiplication are also described in the literature. Other important analog DNA circuit as the amplifier and time circuit. In all of these, the concentration of DNA strands is used as a signal. The DNA strands it gives us input and output also. The speed of DNA circuit is normally expressed in seconds, minutes, and hours. These units may be seems huge compared with the conventional electronic circuits, but the biological process are expressed in seconds, minutes, or hours. DNA strand displacement is a key mechanism used in DNA digital circuits. It involves the exchange of one DNA strand with another in the presence of trigger strand, leading to the displacement of original strand. This process allows for the dynamic reconstruction of DNA circuit and enables complex computations. DNA strands with another in the presence of trigger strands, leading to the displacement of original strand. DNA digital circuit can be designed using various architectures such as DNA enzyme based circuit, DNA origami based circuit, to hold medicated strand displacement circuit. Each architecture offers different advantages in terms of circuit complexity, scalability, and computation power. DNA digital circuits are prone, prone, prone to error due to factors such as noise, unwanted interaction, variations in reaction condition. The applications of DNA circuit. Design of DNA digital circuit has several potential applications in various fields. Here are few examples. Molecular computing and biosensing and diagnostic molecular computing. DNA digital circuit can be used for molecular computing, where DNA molecules are used as an information carrier and computation element. This can be utilized in solving complex computation problems, data storage, and parallel processing. Biosensing and diagnostic. DNA digital circuit can be employed by biosensing and diagnostic application. By designing special DNA based circuit, it is possible to detect and analyze various biological molecules or biomarkers. This can be useful in medical diagnostic, environmental monitoring, and detecting pathogens or contaminants. Drug delivery system. DNA based circuit can be utilized in designing drug delivery system by integrating DNA circuit with stimuli responsive element. It is possible to control the release of therapeutic agent based on specific triggers such as pH, temperature, or presence of certain molecules. It enables targeted and controlled drug delivery. Nanotechnology. DNA digital circuit can be used in the field of nanotechnology to control and manipulate nanoscale devices or structures. By integrating DNA circuits, the nanoparticles or nanomachines, it is possible to program their behavior, enabling passive control over nanoscale process and system. Here we can see in the diagram requirements, abstract diagram, verification, make DNA strands, wet laboratory elements, experiments. Requirements, input, output and rules, abstract diagram, AND gate OR gate, verification, visual DSD, new pack, make DNA strands, IDT, wet laboratory experiment is annealing, measuring the fluorescence. In the first stage, a set of rules which connects the input with the output based on specification in generator. In the second stage, an abstract diagram using AND or NOT gates. Digital circuit is then converted to the DSP program language and DNA strands required for designing the circuits are generated. These strands are further optimized and set to DNA sequencing companies to create synthetic DNA strands. Strands are then used in wet laboratory to create the logical circuit and tested. Thank you.